So today I'm going to be talking about Azure Databricks and Azure Synapse Analytics. And for those of you who attended the Virtual Path Summit, it's a similar session, but as you know, Databricks and Synapse have changed since then. So has this content. So it's not the same thing that I presented at PASS. But I always get questions when using Synapse. Hey, well, why should I use Synapse? When can I use Databricks? And I'm going to talk about what the different products do so that you can answer those questions, not just in the generic, but specifically in your environment for what you want to do. So that's what we're going to be talking about today. So a little bit about me. My name is Ginger Grant. I am from Phoenix, Arizona,
Ginger,
and it's
yeah. I think you have to share your screen again.
Oh man, yeah, because I didn't, and you did. Sorry about that. Go back. Thank you. All right. That probably works better now, huh? You can see my screen?
Yeah, I can see the screen, and it works better, definitely.
All righty, my bad. All right, a little bit about me. I am from Phoenix, Arizona, which is the part of the states where it gets over 40 degrees for a couple months. So right now it's great. And I am a Microsoft Data Platform MVP. I do a lot with Synapse and also Power BI, and I'm also a Microsoft certified trainer. I blog at Desert Isle SQL, and I'm on Twitter quite a bit at desertisleSQL.com. So if you want to get a hold of me because you have questions afterwards, that's probably a really good way. And I've also listed my email there as well. All right, so we're going to review the similarities between the different products. We're going to be talking about what you can do in Databricks and what you can do in Synapse and how they are alike and how they are different. You know, what's the difference between the two of them? Why would you want to use one over the other? What features does one have that the other does not? And then we're going to be looking at matching those application features to use cases in your environment. If you're doing X, which tool should you use and why? So we'll go from there. All right. So with Azure Synapse and Azure Databricks, the idea is that there's a lot of things that they can do that are the same. They can both analyze data in a scalable fashion. Both of them are built on top of Azure. So they use Azure Active Directory Security and allow you to do a single sign-on as they both operate in their own environment. So when you click onto either Synapse or Databricks, you're going to need to go into the environment to then go take a look at it. They both operate in that data is scalable from compute. So what this means is that you have the option to increase or decrease the server that you're using to run your code on at any time. Both of them turn off the compute after a default period of time so that it's not running in perpetuity, bringing up your Azure bill. They will both turn off by themselves. But when data is separate from the compute, this means that if you want it to go faster, run it on a different server. Your data is not tied to your compute in any way, shape, or form, which is really similar to Microsoft's kind of like modern way that they're working on doing development. Both of them use workflows to process data. They both contain different kinds of pipelines, and they both can be incorporated into existing ADF pipelines. So if you want to run a nightly job, no problem. If you want to run it based on an event within ADF, no problem. They both will do that. They both have different scheduling that is incorporated as part of the application so that you can get notified, et cetera, when the job is running, when it completes, when it's successful, when it's not successful. Both Azure Synapse and Azure Databricks were built on top of Apache Spark and use Apache MLlib to do machine learning. The Spark component was originally created to do machine learning. They were trying to win a contest to determine who had the best Netflix algorithm. And so they developed Spark to be able to do that. So underlying Spark was designed to process things in an iterative fashion very quickly. And that is the people that generated the open source version of Spark went on to create Databricks. And so what they had in mind was, we want to create an environment where we can run Spark components and run them very, very quickly and turn off the compute when we're not using it and make it a totally cloud scalable. Both of these products are cloud only, that you cannot really perform them other ways. Now, yes, you can write the code that you are running in Spark somewhere else and then load it up to the environments. Both of them are like that. They both use notebooks, connect to Azure data resources such as data lakes for their sources of data. And they both use multiple languages. If you don't know Python and you know Scala, you can use either one of those. And then the other languages, that's when things start to differ a little bit. So the shared feature set, what do they contain that's the same? Well, one of the elements that they have in common is something called Delta Lake. And Delta Lake is something that is really getting to be more popular to as a method of organizing and accessing data stored within your Azure Data Lake Gen 2. The idea with a Delta Lake is that you're kind of making a flat file act like a SQL database, in that you will specify the structure. And if the structure does not look like how you want it, it'll be set aside. And Delta Lake also contains something called time travel, which is basically database logging. So you can go back to a certain period of time and take a look and or process data based on that period of time. They both contain Delta Lake, but they didn't implement it the same way. And we'll be talking about those differences. They both have Anaconda loaded for Python, which is the most common large library used in Python, so that all of those elements are automatically created. They both actually manage libraries based on the compute or the cluster. So if you wish to have specific libraries for either one of them, you need to load that on the compute. And then, of course, you can use any additional Python libraries that you wish to use. They both use notebooks. They use a different flavor of notebooks in their environments, but what the major difference is how they format the markdown. So not a whole lot of differences between the two. They use Azure Active Directory integration, which means that your tenant does manage who has access to Synapse and Databricks. They're both used for both batch or streaming because that's native to Spark, so you can use them in either fashion. And they both have source control integration with DevOps and GitHub. With Synapse, this was added in late November, and it was one of the last features that was added prior to Synapse going to general availability, which it did, I believe, was on December 4th. And so you can integrate whichever source control component you wish to use so that your elements are safe and secure, checkout, etc. All right, Azure Synapse. Let's start talking about some differences. So it was introduced in November of 2019, and when it first came out, it was the replacement for Azure SQL DW. And so a lot of people thought, well, okay, so that's great. So they just renamed it. It kind of makes it confusing because, yes, Azure Synapse Analytics does contain the data warehouse, but it's a little bit more than that as well. But if you want to run a data warehouse within on Azure, you would be using Azure Synapse to do so. The technology changed a little bit in 2019 when they migrated from Azure SQL DW to Synapse, and they added some additional features. The features are around workflow priorities, so you can really specify that the data is processed very quickly for users or sets of users, and that's a big difference from Azure SQL DW. For those of you who are wondering if it's a lot like Snowflake, not really. because you still need to do the different analysis of your data, determine how you're going to, which structure that you're going to do and how you're going to partition it. So it's still more like Azure SQL DW than it is like Snowflake, but it does separate compute from data so that you can make it go faster. Azure Synapse is built on Azure Data Lake Gen 2. As a matter of fact, when you create a Synapse workspace, you will be asked either to create an Azure Data Lake Gen 2 to use with Synapse, or you will you're going to be asked to connect to one that you have. So it's a fundamental part of the application. But it also contains, in addition to those elements, it contains 3 different ways to process data. And we're going to take a look at those. So Databricks was added to Azure in March of 2018. It was actually added to AWS in 2017. So it's been around for obviously quite a bit longer. And it was developed by the creators of Spark as a Spark improvement. So it was meant to correct all the mistakes that they made when they first went ahead and created Spark. So the idea with Databricks is it was designed to be an environment that you developed in with people rather than in like a one-off thing that you're doing by yourself. So it's a very managed team environment. One thing that I really like about Databricks that does not in Synapse is you have the better ability to sharing notebooks between people. You also have the ability to give different rights to users, allowing people to do things like create additional compute clusters or not, and read and execute, etc. And that's part of the managed team environment that Azure Databricks provide. Do a little bit feature comparison difference between the two. So Azure Synapse is running Spark 2.4 and Azure Databricks is running Spark 3.0. Spark 3.0 came out in, I'm trying to think, June of 2020. They do a really cool conference. On the last one was in December. They do one in Europe and they do one in the States. And that's where they release all the new cool features. And Spark 3.0 came out in, for that previous one in June of 2020. Spark 3.0 contains a number of different improvements over Spark 2.4. One of them is that the SQL that you write now in Spark is fully ANSI compliant, which is kind of a nice thing when you're writing SQL within Spark. And there are some other features and performance enhancements added to it as well. It also it implemented a data structure called koalas better. And there are some improvements that were added to Delta Lake that exist as part of that Spark 3.0 implementation. The compute that you are using either on Synapse or on Spark has different names. It functionally operates the same way. But they don't call it the same thing. So if you are running a server on your code and you are in Synapse, that's called a pool. It's specifically called a Spark pool. And in Databricks, it's called a cluster. Now at Azure Synapse, it uses Transact SQL, actual T-SQL, and Databricks uses ANSI SQL. The languages that they both support in common are they both support Scala and they both support Python, but Databricks supports R and Synapse does not. Synapse supports .NET and Databricks does not. So depending on the language that you choose to write in, that may dictate which one you wish to use. I do not know that there is, we'll put it this way, I've not heard of any work being done to develop R as part of Synapse. So I have no idea, and I would think that I would have heard of something if they were planning on including it. So I don't think that is something that's going to happen anytime in the future if that matters to you. Of course, Synapse is a much younger product. It went GA on December 4th, 2020, and Databricks has been in Azure since 2018. So I did ask Microsoft about the Spark 3.0 versus 2.4 difference because that's kind of a big deal. And I was told that, it is, and I know where to look for it. It is on the roadmap, but it's not in there. So, well, for what that's worth. All right, so let me take a look at walking you through the different products and what to see what they look like internally.
Ginger,
questions?
before you,
Yes.
yeah, there's one question that I do want to get in here now before we go in further.
Sure. No, happy to take questions.
Arno wants to know if there is a difference between the integrated data lakes and like the external data lakes, similar to limitations that we have in Power BI on the built-in data lakes for Power BI data flows and the one where we use bring your own data lake storage.
So if you, let me show you what I'm talking about here, and then I'll answer the question and show you all at the same time. The TLDR answer is no difference. And I'll show you what I mean by that. So within a workspace, it will tell me that I've got a primary, where's that? I've got a primary data source, and I can go ahead and change that. Let me show you where that is in here. So if I choose to do that, that means that I'm just using something that I have existing. So if I use existing or if I create an existing data set, it doesn't matter to me, and it doesn't functionally operate any different. But something is default. One of the things that's actually good about having additional data sets that are external to your Synapse environment, you might have something in a different location that you want to access. And of course, you wouldn't want to do that all the time, but functionally, there's no difference. You just have to have something that's default, and whether you create it or whether you add it, it doesn't matter. But it will be listed within here, and you can put as many as you want. You see here, I only happen to have one in this particular instance of Azure Synapse. I will say though, when you're talking about data lakes between Synapse and Databricks, there is a difference, because the data lake that you use within Azure Synapse to do things like queries is data that it exists in a flat file format, and it does not use Delta Lake. So I can, of course, use Delta Lake, but not when I am querying data or looking at data that's contained in my default Azure Data Lake that I would be using for querying. So one of the things that's really cool about what I'm showing you now is that this is just a flat file that I have stuffed out in my data lake. So I've got these different Azure Data Lake elements here, and if I want to take a look at them, I can load them to a data frame, load them to a Spark table, and query my data here. So, and this would be just to run this and create it and take a look at my data within my data lake. So it's automatically going to write the SQL for me and query it as well. But I also have the ability to do that when I have data in my data lake by looking at it in SQL as well. And if I select it here from the Azure Data Lake Storage Gen 2, you can see this is a notebook that it created to select my DIM customer data. If I select it within Azure Data Lake Gen Storage, same exact file. I can use this to select rows using a SQL statement. And it automatically creates both of these for me. And I can go ahead and execute this and run it to take a look at my data. So one of the things that is really amazing that you have within Synapse is the ability to query flat files as if they were data. Now, this particular one I have is a CSV, and by default, CSVs do not put headers in the generated code. Of course, I can change that so that it will. But this allows me to take a look at a flat file as if it was an actual table. Now, granted, it's a little slower, but it's a really great way of browsing and reviewing the data that you have within your data lake. So this is some of the features that were in that are in Azure Synapse. If you are interested in creating a workspace in Synapse, it's a relatively easy process. I won't bore you with how to do that because there's 80 million places that have shown you how to do that. But what you do is you create this environment, you open Synapse Studio, and this is where you learn about different elements within it. I will say that if you want to get started on it, you haven't played around with it, this Learn section here will allow you to take a look at code that it runs for you. So you can browse the gallery and actually take a look at any data sets, notebooks, SQL scripts, or pipelines, that all of this is sample code that works, which is kind of a neat thing. Going back to the home here. Come on. Don't make me do this again. Being impatient. So I have different elements here. I've got my home section, which is just my various landing area. I've got data where I can create databases. There are, of course, two different kinds of databases that you can create within Synapse. One of them is a SQL data warehouse, which is what this is here. So I've got a Synapse data warehouse. I currently have it on pause. So that is why I'm getting that stop mark there. And then I have created external tables within my flat files, and that also exists as a database. So I've got an actual SQL data warehouse, and then I've got this Synapse database that I've created. I can also create Spark tables, and I can create tables within Delta Lake within Spark. So I've got different options of how I can organize all of my databases, and I have options within Synapse. Underneath Develop, this is what you would see that looks quite a bit like what you'll see in Databricks when I look at that next. And these are different scripts that do various tasks to get data, run data. This would be to create a database. This is to select data, making sure that I have the header row on there, getting data from different elements of my data lake and other elements here. So this is my SQL scripts. I also have notebooks, and within my notebooks, I've got different code that I've created to do, in this case, a classification experiment within machine learning. On the next element that is within Synapse is something called Integrate, and Integrate is ADF. They ported the code to Azure Synapse. So if you actually are looking at the data, if you're actually doing a lookup in the documents and you are looking up something in ADF, you'll also notice at the top it says also Azure Synapse, because it's the same code. They just forked it slightly so that there are a couple of things that are different. But if you look at it, you'll notice that it looks very similar. One of the things that Synapse has that's not present in Databricks is a lot of no-code options, so that you can, say, create a Parquet file, do that completely within this ADF environment, and not have to write any code, do the clicky, draggy method for being able to do that. So this is, my source would be here, and this is my data set. So if I open that, I can see that I've got a CSV file, and I can take that and format that as a Parquet file, which is in my sink. And I've created that over here in a different part of my data lake, and that's all that this particular job does. Now, one of the reasons that that's kind of an important thing is that Parquet files kind of act like column store indices in that they are compressed. So if you are using either Databricks or Azure Synapse, and you're keeping your data in a data lake, it's more efficient to store them as Parquet files because they are compressed. And so you're like, well, I don't have any Parquet files. You can create, I created this little job to create myself a CSV to Parquet file, and it took about 15 minutes. So that's kind of the beauty of this like low code, no code option, because there are a number of different wizards that you can do to create your pipelines if you're not very good at them. So that is integrate. Monitor is where you have the different elements that you are running within Synapse. So here I've got my pipeline runs. I haven't run anything in the last 12 hours. So this is where you're looking at my job. So my pipeline runs are integrate. I can run it on a trigger, so based on an event. And I also have an integration runtime. Integration runtime is another Spark cluster that is created when you create a Synapse workspace, and it's running, but you're not charged unless you're using it. So don't worry, need to worry about that. Yes, you can turn it off, but since if you're not using it, it doesn't charge you, so it doesn't, no really point in doing that. For Spark applications, I am running a notebook, so it shows that this is running. If I was running any SQL requests here, this is the last one that I requested, and this is basically showing you what was run. I can do different data flow debugs. And last thing I have under here, monitor, is my SQL pool. You get there are two different kinds of pools. Again, pools in Synapse are the same as computes clusters in Databricks. So these are my servers. So I've got a built-in way that I can use to query SQL. This doesn't charge me at all until I'm running something. And then I've got my data warehouse, and my data warehouse pool is, I'm charged every minute that it's up, and that's why it's on pause. I see that there's a question that popped up that said that integration runtime is specifically for hosting the components ported from ADF. Yes, integration runtime specifically, this is the compute engine that it runs on. And you can create more of these. So you can create an additional compute cluster that is larger or smaller than the one that's automatically created. This one is created, though. The auto resolve integration runtime is created when you create a workspace. So this is the server that your ADF components are running on. So hopefully that helps answer your question a little bit. Does Azure Synapse mean ADF plus SQL? I'm using SQL and ADF separately, and if that means if I use Azure Synapse, does it mean I won't need ADF and SQL Server? You do not need to, if you choose, again, optional, you can replace ADF with Synapse. So because it's the same code, you can run it within, you can write all of your ADF within Synapse instead of through ADF. That is definitely an option. In terms of if you are using SQL separately, if you have an Azure SQL DB that you are using as your source, you could, obviously continue to use that as the source of your data. Right now, there is no way to directly connect to an Azure SQL DB within Synapse, but that is on the roadmap, and I was told that that will be done soon, and I have no idea when that is. But that is something that in the future you would be able to query an Azure SQL DB from within Synapse as well, although not today. So I could take a look at, these are my pools again. My dedicated pool for data warehousing is turned off because I'm cheap, and every minute that runs, I get charged. This is my Spark pool. I presently have one Spark pool. I have it sized as medium. You can do the t-shirt sizing that Snowflake does, where you pick the different size of Spark pools you want. There are limits to how much you can have running based on your Azure account. So you can't run all the Spark pools that you wish because you will eventually run out of memory. This Spark pool is by default set to turn itself off after 15 minutes of inactivity. And this is showing me, like what it's doing now. It's got one active application that's running now, and then shows a little bit of the history that I've got going on and anything that's added. So this is all like a very kind of a new environment that they added a couple weeks back. And then you've got that was monitor, and this is manage. So with manage, you can take a look at the properties of your different pools. You can here take a look here. Just this is under manage. I can see the URL. I can see this is the configuration here, showing you the different versions that are available. And here you can see these are my linked services. So this is the code that I've created within ADF, showing the different link server and also that are created as part of this. Triggers, anything that I've created to automatically kick it off. My integration and runtime, which this particular one is created when you create a Synapse Workspace. I can look at access control. I've got myself and a service principal, and I've got a managed identity here, and I am using source control, and I'm using Git integration. So I used both Git integration and DevOps just to make sure that they both work. You know, when you have your Git integrated, the difference that you will see is, notice you'll see it up here, and you will get the ability when you tweak something, you'll get this element here that says, you know, if you change it, you can commit it. So you have committing and publishing, which is two separate areas. All right, so what is Databricks like? So Databricks, I accessed my Databricks through the Azure portal. It has a similar home section here. It is a little bit lighter on the features because this is really an environment that is created to run jobs in Spark. So it's got notebooks, tables, clusters, jobs, and imports libraries. So you can create different workspaces, organize your elements up, take a look at create different notebooks, create folders. I didn't show you that, but you can also create folders in Synapse. It'll show you your recent elements. It'll show you your tables that you have. You can access data that temporarily from within Databricks, and you can also create a cluster. If you haven't used this in a while, and I used my previous account before, so I'm just going to walk through creating a cluster here. I don't have any available clusters because they get deleted if you don't use them. No big deal. So I'm going to call this one Shoya because I tend to name my clusters after cactuses, and that's the type of cactus, believe it or not. So I've got standard, high concurrency, or single node. High concurrency means that I've got more throughput. I don't need that. Pools, I don't need pools for this. It's a cluster, so pools is kind of if I wish to pool my clusters together, I could. Then I have my Databricks runtime versions available. This list changes periodically so that you can always get the latest and greatest, but the old ones are available. Since Python 3 is now the only supported one, when this first was implemented in 2018, it did also support Python 2, but that went away. The auto scaling will allow it to use more clusters as it needs the resources, and it's going to terminate after a certain level of inactivity. It originally said 120 minutes. I'm cheap, so I'm going to go with 45. Under the workers, this is telling you the different types of compute that you can possibly select. One of the things that I wanted to bring up here is you'll notice here, I don't have rights to this because of my account is got too much compute allocated already, so I'm out of resources. But this GPU accelerated provides the ability for you to select graphical processing units, which improves the performance of your engine. And like I said, the reason that I've got this message here is because I don't have enough CPU left. This is an issue with my tenant, but that's okay. I have this much available, and I'm going to go with the standard. So I'm going to get 14 gig of memory and 4 cores. And I can do on premium, I can do get a storage credential pass through. involves tighter configuration. One thing that I didn't mention is that there are different versions of Databricks, and there is only one version of Synapse. So you have premium and standard within Databricks. So I'm going to go ahead and create cluster, and this is going to provide the compute engine that I have for running my Databricks code. Question, does the GPU acceleration specifically improve AI ML applications or also regular ETL transaction type workloads? So adding graphical processing units will be implemented when your libraries access them. So if you have written, if you know if your code will do it, like Spark automatically will use graphical processing units. So that's not really an issue, but you can use anything. I mean, it just makes the code run faster because you're using additional cores. So any library that you create that allows access to that GPU and its underlying level can profit from it. And I will say that now that most do, but not all. So yes, your ETL can be improved by using GPUs. Like anything else, when you are running compute in Azure, there are costs involved. And guess what? GPUs are a little bit more money, a lot more money actually, than some of the other elements. So if you really need it to go faster, great, you will pay for it. So keep that in mind when you're selecting it. But if you need it to go faster, you will get it to go faster with GPUs than you will with larger clusters, if that helps. But again, they're very expensive to run. One of the things about both of these computes is they are relatively compatible when it comes to cost. But you are charged when it is up and based on how it is scaling given the jobs you're running. So, and they both work the same way, and you have to have a cluster running to be able to do anything. And in a environment, in my Synapse environment, I have to have my pool to run my Spark job here, and you'll notice that it's not running at the moment, so I would need to kick it off before doing that. So that's how they work. So they're obviously, I mean, the environments are obviously quite different. Jobs, this is where you create jobs that you run automatically. So I'm running these on a schedule. These act a whole lot like SQL Server agent jobs. So I can create this job to run on a schedule. I could also choose to create something that I call from within ADF. So I do not have to use this job environment within Databricks, but it's definitely an option. It allows you to deploy your machine learning models to Databricks. I don't have any in this particular one. And then go ahead and search, try to find stuff because, you know, code gets difficult to find over time. So any other questions about these two environments? Great. All right, we'll go back to slides because one of the things that I'm doing as well is I'm running some code, so which I look forward to showing you because it just finished. All right. So we took a look at the two different environments. Let's talk a little bit more about some of the differences between the two, some of the stuff that I showed you, get more meat on it. So what you might have noticed when I walked through Azure is that it's more than Yazdi. So I got Yazdi from one of the people who works on the Microsoft product team. Thank you, Ewan, if he ever listens to this, which I don't know he will. He said that when I did this presentation originally, I asked for his input, and he said, well, you didn't have anything in there that was factually incorrect, but you kind of forgot to mention all the other stuff that Synapse does that Databricks doesn't. And I'm like, oh, good point. Went and redid my deck. But it's more than just yet another Spark interface, which is what that stands for. Yes, you can do Spark in both environments, and it'll perform very well. That's not a question. But many people use Azure Synapse and never touch Spark because they've got a data warehouse. So, and they have ported their ADF over. By the way, there's no really easy way to do that yet. If you're thinking about it, I heard that there's something that they're working on, but you can use Synapse and never touch Spark, never write Python or Scala. But that's not the case really with Databricks. That's what you're using it for. So it has integration with a number more Azure services, go figure, including integration that we'll take a look at with Power BI, so that you can run Power BI straight from within Synapse. And you can also, which is what I think is a really good use case for, well, I guess it's a use case for Synapse because it makes it easier to do. But with Synapse, it's very easy to create, not that you can't create it with other tools, but it's very easy to create a data lake Gen 2 flat file environment. Now, we're talking about not like ridiculously large amounts of data, but you can use that as your data model within Power BI by connecting to a portion of the Azure Data Lake that you may have organized up within Synapse. So that is definitely an option that you can do. It actually one that I have implemented for a client. So that is another option that you can do with it. And the other thing that Synapse and Microsoft is really kind of pushing is that they know that there are people out there that are new to this. They haven't written a lot of code yet. And their boss tells them that they have to get something done. So there's incorporated a lot of no code features or low code features. And I do consider integration with ADF. Yes, if you're good at it, you do a lot more than wizards, but you can get away with the wizards. There also are components that allow you to do machine learning automatically so that it will pick a model for you. And that is a UI feature. There is also a UI feature to create cognitive services and implement those within Synapse. Again, low code, no code option. Of course, you can still write code, but they're trying to help people out who don't know. So when I say that what you can do with Synapse, this is pretty much the entire environment. So it contains a data warehouse, the serverless pools, those are the areas that allow you to query your flat files. You've got integration, which is ported ADF, and then you've got your Spark notebooks. In addition to that, now these, in addition to these elements, you've also got integrations into Power BI, Azure ML, Cosmos DB, DevOps, and GitHub. So, okay, these two also are in Databricks, but the Azure SQL DB is going to be coming soon, so that will be ported. If you've ever messed around with Cosmos DB, it's kind of a pain to query that, so it's very convenient to be able to query that from within Synapse in the serverless pools. You query it just like you do SQL. So kind of a nice thing. All right, only in Synapse, integration with Azure Link Services. Azure Link Services is a component, a concept really, that they stole from ADF. And that allows you to link into other applications. So with the Azure Link Services, you link into Azure ML, you link into Cognitive Services, you link into Power BI. And you also will be linked. Also, I forgot to put on there that you link into Cosmos DB and soon as SQL, so you can basically contain and move around within it. Synapse is the only one that has data warehousing. It is the Azure. If you want to put a database in Azure and you have it's over 1 terabyte, it's designed for Synapse. I wish it was called something else because that's Synapse too, but it's what the actual name within Synapse that it is called it's called a SQL pool. So SQL pools is a data warehouse components. Querying around the text, that's a serverless SQL pool. So, all right, so if you have multiple environments in the pipeline, then you will not be able to use no code, or you could do the same steps in each environment. Okay, so depends on what you're talking about. For the no code part where you're talking about ADF, it creates the components for you, and then you can add those to source control and move them to wherever you want. Because actually I had a customer where they had an employee that basically he did the wizards for Synapse, which is basically like ADF, to move code around. And that was in dev, test, and prod. So you can, for the elements that are in machine learning, what you get out of that is you get a model and then you move the model around. So, and yes, you can put that model into source control and it will create, it's not going to create the code for you for that if you use a no code environment. And the same for cognitive services, I'm not sure if what you get as the output of. I know what you get with the output. I'm not sure about dev, test, and prod with cognitive services. That's a good question. I will find out the answer for you. But you can also do T-SQL queries, and T-SQL queries is also only in Synapse. So what can you do with T-SQL? You can query flat files. You can query Cosmos DB. And you can someday we'll be doing Azure SQL. Flat files, you can use any kind of flat file structured format. Soon they will be the one that is the most quick is Parquet. So if you are looking to do long-term storage and access of your data that you have in Data Lake, change it to Parquet. So that it will be able to both decrease the amount of storage space that you need, decrease Azure spend, and you'll be able to query it faster. All right, only in Synapse. Synapse has integration based on Data Factory. Yes, you can do integration within Databricks, but you're writing all that code yourself. The code runs in the integrated runtime, and that is also a Spark cluster as well. And you can use it to incorporate, and this is the little part that's a little bit different than ADF, but it only makes sense, right? Because Synapse has notebooks. So you can call the notebooks that you create within your pipelines, which you can't do within ADF because you don't have access to the notebooks. So you can also, if I created a persisted table, so what do I mean by that? Okay, let's say that I've got a flat file. And my flat file has, let's just say it's got 15 columns, right? And I only care about 10 of them. I don't care about those other 5 columns. What I can do is I can create a persisted table. And that persisted table can be defined on only the 10 columns that I care about. And then when I have that table persisted, then I can use that as part of any notebook or integration runtime that I want to as a actual table, even though all I'm talking about really is an overlay on top of a data lake. So that's what a persisted table is. So, and that's the kind of thing that's, again, specific to Synapse. Only in Synapse, data warehouse. If you want a data warehouse, you can't do that in Databricks. That's something that you do in Synapse. High performing access to big data. Big data, if you don't have a terabyte, don't bother. One thing that also, if you are doing data warehousing within Azure Synapse, you are going to be using, as I talked about before, SQL pools. And SQL pools are dedicated resources for your data warehouse that you are charged for every minute they are in operation. Now, you could always pause them. And when you do, your data doesn't go anywhere. So, for example, I had a client, they had a data warehouse that was primarily used for reporting and analysis. And that database is up from 7 a.m. to 7 p.m. Nights, weekends, if you open up a ticket, they will run it for you. But other than that, no, it's closed. So any kind of standard data warehousing tasks that you have with your data warehouse, that is available within Synapse. Another thing that you can do within a data warehouse within Synapse, if you have created a Azure Machine Learning registered machine learning component, you can use the persist function to execute that component from within your data warehouse as well. So that's a feature that is contained within Synapse Data Warehouse. So Synapse Data Warehouse, that is where you can do querying a T-SQL. If you wanted to query your flat file data within Databricks, what you would have to do is you would be creating a data frame probably in Spark and then taking a look at your data that way. So not exactly the same environment, not T-SQL. This allows kind of a great tool because it allows you to do exploratory analysis, taking a look at what kind of data that you have. You can also create logical databases, meaning that you can pick and choose files and you can say, okay, I'm going to make these into a database. And it's a logical database that you have created within your serverless pools to make that happen. Is querying Delta Lake planned for serverless pools in Synapse? Well, I did mention that you cannot use Delta Lake within serverless pools. I do not know the answer to that question. I know that it gets asked a lot, and I don't know if anybody's doing anything with that for Microsoft or not. I wish, but I don't know. I don't know the answer. I can tell you that if it was something that was going to be happening quickly, I probably would know the answer. So if it is happening, it's not going to be anytime soon. So good question. So you can also in T-SQL create databases connected with link service. Right now that's Cosmos DB, so that I can link my Cosmos DB into Synapse and query it along. Is the building of a dedicated SQL pool done for the minute or the started hour? Again, SQL pools are what's used for data warehouses, and it is rounded to the minute, not the second. So the minute it is on, you are being charged. With serverless pools, which is what the T-SQL part of it is, it's when you run a query and how complex your query is, and you are charged in T-SQL serverless pools for the queries that you run. And the first 5 terabytes is $5. So I don't really worry about the complexity of my T-SQL statements in serverless pools. But with the SQL pools, it can be really complicated or really simple, stupid, and you're charged the same. So that's the difference between the two different pools. All right, only in Synapse, Azure ML integration. So you've got persisted SQL queries, exploratory analysis, logical databases. All of these are with Azure ML and databases connected with link services. And in Synapse, you can do cognitive services. There is I don't have time to do this, but there's a really cool tutorial that shows you how you can implement cognitive services in a no-code environment within Azure ML. And it is in, I saw it in one of the tutorials in Synapse. So send me, if you're interested in how to do that, send me an email or put something in chat and I can send you the link to it because I was just looking at that yesterday. And what cognitive services elements that are available right now are text sentiment analysis and anomaly detection. So these are the only 2 right now, but I know others are planned. I don't know which and I don't know when, but I know the list is going to be longer than 2 at some point in time. So also only in Synapse Power BI integration. So that you can incorporate a workspace for Power BI and reporting. So when you are incorporating Power BI into Azure Synapse, you get a workspace, not all your workspaces, one. So the idea being is that if this workspace contained a link to your Azure Data Lake, then you could do visualizations based on it as well. So, and you can create views for a virtual data warehouse and do things like that as well. So it's a full-on loaded up Power BI integration into of a workspace into Synapse. It loads up from the Power BI service. So you do have to have a Power BI account to make that work. Power BI is not licensed through Synapse, and there you can't do any kind of Power Query experience with that. You can basically do what you can do within the service, which is creating reports off of a single workspace. So All right, so let me take a look at some other elements of Azure Synapse. And one thing that I wanted to show you is the ability to create a automated machine learning from within Azure Synapse. And I did this with code versus the no code environment, but you can do the same thing with a no code environment. And what I'm doing here is I am using an open source data set, and I am trying to determine if a taxi is more or is likely to be tipped or not. And if I'm going to have Azure pick my algorithms for me. So it will run all the algorithms that I specify in terms of how long, how many, what score, and then say this one's the best. So you can just run this and then get an answer for what the best algorithm is, and it will even tune your hyperparameters for you. So to do this, what I am doing is I am using AutoML. And what I'm doing here is grabbing data for 3 months from the taxi data set. And here I'm just showing that data set and format a little bit better here. So I've got vendor, passenger count, distance, etc. And then what I'm doing is I'm going through and splitting my data. And then I am using my Azure ML Workspace. So I've got my Azure ML Workspace from within here and connecting to that workspace, and then using that workspace to determine what to do my picking of my algorithm for me. And again, there is a no code environment for this as well. So I'm saying, hey, enable early stopping, do 5 iterations. I want the primary metric to be the R2 score, and do 2 cross validations. And these are my parameters for AutoML. And this is going to run within machine learning. And it is going to then go pick the best argument, the best algorithm for me, and then tell me what I need to do. So it's going through here. And if you look here, it ran through, was it 37? And it ran through all these different algorithms and then scored them all. And then based on which one had the best score, some of these are terrible. And the reason that some of these are done multiple times is it changed the hyperparameters to see if it made any difference. And it's going to tell me which one is the best score. And then it has these in reverse order. So the best algorithm for this particular experiment is the stack ensemble. So it ran different algorithms for me and told me, hey, I picked the best algorithm. I ran all these other ones. This one worked out the best. And you should go ahead and use this. So what it is doing, let's go ahead and go into Azure ML, and we can see that it ran from within here to determine, to get our results for what's the best algorithm that I could possibly use. So here you can see this is my run. It just was, when it was submitted, it was automated, and it's running machine learning compute for this. And so from within Synapse, I accessed my Azure Machine Learning Workspace, and it ran this job and ran through a bunch of different algorithms and told me that this is the best one because I told it that I wanted the one based on the R2 score. And I can select this, and it'll show me the explanations, the outputs, explain variance, look at my different results, and then I can snapshot it. So the goal, so what I can do now that it has used Azure Machine Learning to select the best algorithm is that I can then use this algorithm, create a model, load the model, deploy it, and be done with it. And know that I let the computer after 2 hours determine this is the best algorithm for determining whether or not somebody is tipped or not. So kind of a neat feature that's available and incorporated within Azure ML and is available from within Synapse. You do have to create this workspace first, which is not terribly surprising. And of course, because we're talking about Azure, make sure that you've got them created in the same data center. Otherwise, you're going to have to pay. All right. I want to make sure that I get to this before I run out of time. What I want to talk about is what you've got only in Databricks. So what features and functionality are available only there? And the big thing is it's a proprietary version of Spark. So when Databricks, when Synapse first came online, I'm like, oh, cool, I'll move my code over. Yeah, it doesn't work exactly the same way. It works differently enough that you can't just cut and paste and have it work. The reason that it uses this is really funny because Microsoft is touting open source and another company is not, even though they're the ones that created the open source to begin with. But Microsoft is using the open source version of Spark. Databricks was created because the guys who wrote it, and primarily Matej Zachariah, who is currently leading Databricks, he knew how to make it go faster. And instead of like giving that away to the world, he decided that he wanted to make a buck off of it. So it is faster to use the proprietary version of Spark within Databricks. How much faster? Depends. 35% maybe. So if you're doing like straight up Spark ML and you want it to go as fast as possible, Databricks will be faster. Now, it doesn't have the cool integrations that integrate directly with ADF, but it does have third-party integrations that are available with it that are really pretty neat. And the compute resources are different. Again, they have GPUs. So it has the Delta Lake is also, well, not only is it the latest version, but it has performance enhancements on top of the fact that it's using a higher version. So this means that if you've got data that is stored in a Delta Lake in Databricks and you are accessing it within your code, it will you'll be able to access it more rapidly. And based on the optimizations that they've done to data lakes under the covers that they're not telling anybody about and not releasing to the world for free. So it is, so this provides this proprietary Spark does provide that advantage. And it's using the latest one too, which has got some features that make it faster. And frankly, getting to write ANSI SQL instead of SQLite, I think is a real improvement from within Python code that I'm writing. So I really wish that Synapse had Spark 3.0 as well, but they do not. It integrates with other language user interfaces with a component called Databricks Connect. And this provides partner integrations to other cloud data sets. And one thing that's really cool with the way that Databricks is integrated is it's much easier to share notebooks within that environment than you can within the Synapse environment. So you can, but it just works a little bit cleaner. And Delta Lake is more fully integrated as well. For example, serverless pools, yeah, that's not Delta Lake at all. So within Databricks, if you've got something defined as data lake, when you are accessing it anywhere within Databricks, you are accessing it as a Delta Lake, excuse me, and in Synapse, that's not true. So only in Databricks, you got that graphical processing unit, so the GPU compute. Does provide the ability to increase the compute and increases the available capacity that you have, making your stuff run even faster. One thing also is if you want the most optimal compute ever, you should probably check the data center that you choose to locate Databricks in, because the higher compute levels are not available in every single data center. Keep that in mind when you are selecting where you want it to run. Know where has the most advanced compute because they differ. And so these do increase the power when you are running components. So, all right, let's take a look at some elements of, oh shoot, I got about 5 minutes of Databricks, but this is not gonna be very intense. All right. So is my cluster. All right. All right, here you can see that my cluster is now running. So I can go ahead and now use this to run different elements. So I've got a machine learning component here where I have loaded up a data set and I'm using it to determine what the cost is for diamonds based upon the characteristics of the diamond. So I can go ahead and run that and see how it is. Now, this is data that I've got within a CSV, but if I want to query it, access it, you know, I'm either using Spark SQL or I could change this to Spark to run this. From an integration perspective, some of the stuff that I thought that I think about this is that is really cool. Oh, there's one thing that I forgot to put in the last slide. If you were doing streaming, especially if you were streaming with Kafka, you will probably find that Databricks is a better environment for you because the way that it handles streaming is more performant. Again, that has to do with its proprietary version, but streaming, if you're planning on doing a lot of streaming, I think you'll find that the performance improvements in the proprietary Spark cluster are something that you'll want to take advantage of because that's significant. All right, so I can go ahead and create different groups of users from within my Databricks. So this is a concept that does not exist within Synapse. So I can have different classifications of users and they have the ability to do different things. If you are not an admin or a super user, you cannot create clusters. So that limits the availability of that. You can limit cluster creation, of course, within Synapse, but it's more tricky. And with Synapse, if you don't have, they do not have the distinct variations in security that are available within Databricks. Just kind of leave it at that. Workspace storage, you can purge your workspace storage. So what workspace storage is for temporary analysis purposes, you can load something within the Databricks environment. It's just faster, but you don't want to do that if you've got a lot of data. That's just kind of what you want to do if you're playing around with a little bit of data. And that's probably why you want to purge that periodically. Access control, you can change different levels of access from within Databricks. And then you have different types of security that you can add to the environment. One thing that's interesting that they have this download button for notebook results enabled or disabled. This is not a concept that exists within Synapse. So the different levels of granularity here is not something that Synapse provides. So these are additional features that it has that are not found within Databricks. All right, I want to finish up here. So which is the best fit? Well, what are you trying to do? If you are looking to integrate Python and do some ADF, hey, Synapse will work really well for you. If you want to do data warehousing, yeah, that's all Synapse. If you want to write your Spark code in .NET, that's clearly Synapse. And if you want to be like a big open source advocate, you want to go Microsoft, which is just funny to me. But they do have the open source version of Spark. Databricks, if you are doing streaming, you'll want to do it, and you'll want to do it in Databricks. That's really important to you. If you want the latest Spark features, then you will want to use Databricks. If you want to write in R, and if you want that proprietary version that makes it go faster, that's Databricks. So, but think about what you're doing when you pick. You can use both because you can call Databricks jobs from within Synapse, and you can use Databricks for targeted tasks. and Synapse for data warehousing, and then create data lake houses with serverless if you want to. So figure it out, which is the best one in your environment based on the kind of work that you're doing. And in summary, we talked about the common elements, we detailed the different features, and then kind of reviewed which ones were important. And with that, any questions that I didn't answer during it? Under the category random questions, is that a Synapse sweater in the background? Can a non-MVP mortal get his hands on and annoy his Snowflake colleagues? Yeah, you need to suck up to the product team.
Even MVPs don't get Synapse swag by default because I don't have any.
No, so basically, yeah, I'm in with the product team. So they give me nice stuff because I say stuff about, so that's how you do it. Oh, you've got one from Ignite. Oh, wow. So that's the only way you get it. And I was absolutely thrilled. I got a t-shirt too, so, but yeah. You got one from Ignite. Any other questions? What is your recommendation on source control of notebooks and deployment? Have 3 environments like you would anyway, and save your notebooks. And it's basically like it's code. So how you would do your code is how you would do notebooks, you know, with in the same environment, same DevOps capabilities you would, or functionality you would use otherwise. So anything else? Well, I know I'm a little bit over, but thank you very much. I'm really happy to be able to be asked to speak. I was at DataMine some years back, and my big regret was not spending more time in Belgium. So next time I'm going to spend longer. What's the difference with the pipelines that you mentioned? I can't just port my ADF pipelines to Synapse. So you can port your ADF pipelines to Synapse. I'm just saying there's just not a real easy way of doing it. Yes, it is exactly the same, but there's no
migration experience.
Yeah, that's what I'm getting at. They are looking to do that. And I was on a phone call, like, yes, we are evaluating that. Okay, that's what I know about it. But yeah, if you want to just do all your ADF from Synapse, go for it. If you deploy from Azure DevOps, that shouldn't be a problem, right? No, it shouldn't. Will there be pipeline templates like in ADF? I don't know, but I imagine so because they're going for full compatibility. Oh, yeah, by the way, they've made sure that price is the same too. So there's no price difference if you use ADF or Synapse, and they did that on purpose. So yes, there are. Okay. Any other questions? If you can't think of them now, but hit me up on Twitter at DesertIsleSQL, and I'll be happy to answer the questions that you have there. Anything else? All right.
I don't think there's any questions left.
All right.